Good morning, Chairman Lamburn, Ranking Member Holt, Congressman DeFazio, and committee members. I want to thank the Chairman and all the members of the committee for the opportunity to submit testimony on a West Coast earthquake early warning system, as well as for your leadership in holding this hearing. I am Douglas Toomey, a professor of geophysics at the University of Oregon. I lead the Cascadia Initiative, a 4-year project funded by the National Science Foundation that features the largest array of onshore, offshore seismometers in U.S. history. Today I will emphasize the unique opportunities for an earthquake early warning system in the Pacific Northwest. A magnitude 9 earthquake and tsunami, comparable to those that occurred in Alaska in 1964, Sumatra in 2004, Chile in 2010, and Japan in 2011, has and will again hit the Pacific Northwest. The source of this devastating earthquake will be the Cascadia subduction zone, which lies offshore beneath the coastal areas of Northern California, Oregon, and Washington. It's been more than 300 years since the last great earthquake and tsunami along Cascadia, and we're in the window of its reoccurrence. The Pacific Northwest is unprepared for catastrophe of this scale. Moreover, because the Cascadia fault zone lies offshore, we do not understand it as well as onshore faults, which can be monitored through easy and relatively inexpensive means. An earthquake early warning system is well suited for the impending magnitude 9 earthquake on the Pacific Northwest coast. This is because the most powerful earthquakes in the Pacific Northwest occur along a fault that lies primarily offshore as opposed to directly beneath major metropolitan areas. Given the immense length of this fault, if it were to begin rupturing in the south, as research indicates, Portland could receive a warning as much as 3 minutes, and Seattle as much as 5 minutes, prior to the arrival of heavy shaking. Even in Eugene, Oregon, where I live, our schools, businesses, and hospitals could be warned by as much as 2 minutes before the shaking starts. 2 minutes is a long time. I asked the principal of a local elementary school, which was built in 1926, how long it would take to evacuate all 350 students. The answer, 1.5 minutes. This is just one of 1,000 schools that a recent state of Oregon study concluded would collapse in a magnitude 9 event. Only a West Coast earthquake early warning system can provide advanced warnings that will save lives, protect businesses, and facilitate a more rapid recovery for local communities, the federal government, and the economy as a whole. To further drive home just how unprepared the Pacific Northwest is, consider the map being projected. The map shows seismic stations operated by the Pacific Northwest Seismic Network. Observe the near absence of earthquake monitoring sites within a large red circle encompassing southwestern Oregon. If we presume that the next massive earthquake in the Cascadia subduction zone begins in Northern California and unzips to the north, then it is obvious that our current capacity to detect earthquakes in this crucial region is woefully inadequate for protecting society. Once an onshore earthquake early warning system is built, it must be extended offshore. Studies in the wake of the recent magnitude 9 earthquakes in Japan and Chile show increasing evidence that subduction zones, like Cascadia, shimmy, sometimes for days and even weeks before they shake. To investigate this, scientists are deploying ocean bottom seismometers directly above subduction zone faults. The NSF-supported Cascadia Initiative, for example, has deployed hundreds of seismometers along the coast of the Pacific Northwest. These seismometers form the potential backbone of an offshore earthquake early warning system, but the current method of retrieving data, which is done by ship once per year, is impractical for that purpose. If seafloor cables attach the seismometers, they could provide real-time, near-field monitoring of the Cascadia subduction zone. By altering the function of instruments that are already in place on the ocean floor, we can fundamentally transform our ability to monitor Cascadia. In the event of a magnitude 9 earthquake, cabled ocean bottom seismometers will increase the warning time and make earthquake and tsunami warnings more accurate. Cabled ocean bottom seismometers will also accelerate discovery by allowing scientists to better monitor the creaks and groans that occur prior to catastrophic failure. Once again, Mr. Chairman and the committee, I thank you for your leadership on this vital issue.
Thank you. Dr. Allen.
Chairman Langborn, Ranking Member Holt, members of the committee, thank you for this invitation to testify at this hearing about bringing earthquake early warning to the population of the United States. As we've heard, the earthquake risk along the US West Coast is substantial, and it is too easily forgotten. We must remain vigilant and push forward with new and improved ways to reduce this risk, and earthquake early warning presents one such opportunity.